Right now, more than 21 billion kilometers from wherever you're sitting, past every planet, past the outer edge of the sun's reach, a machine built almost 50 years ago is still switching pieces of itself on and off just to survive. It runs on less power than a household light bulb, and it loses a little more of that every single year. And when scientists took the raw electrical readings this spacecraft has been sending home and fed them through a speaker, what came out was a sound no human being had ever heard before. Not a voice, not words. Something stranger and something real. Before you assume this is another one of those headlines about a hidden alien signal finally decoded, it isn't, and understanding what it actually is turns out to be far more unsettling, in the best sense, than any fake transmission ever could be. This is what Voyager 2's deep space data actually shows, why NASA and independent researchers have kept going back to reanalyze it, and why the countdown on this machine ever speaking to us again is ticking louder than it ever has before. Voyager 2 left Earth on August 20th, 1977, a little more than 2 weeks ahead of its twin, Voyager 1. The original plan was modest: fly past Jupiter and Saturn, take some pictures, gather some readings, and drift into silence once the funding and the fuel ran out. Nobody who built it expected it to still be alive and transmitting data nearly 50 years later. What changed everything was a rare alignment of the outer planets that happens only once every 176 years, one that let a single spacecraft use each giant planet's gravity to slingshot itself toward the next, saving decades of travel time it never would have had otherwise. Voyager 2 remains the only spacecraft in history to have used that alignment to visit all 4 outer planets in a single mission. It reached Jupiter in 1979 and Saturn in 1981. Rather than ending the mission there, NASA made the call that reshaped everything that followed and sent it onward to Uranus and Neptune, 2 planets no spacecraft had ever approached before, and none has visited since. At Uranus in 1986, it found 11 new moons and 2 previously unseen rings. At Neptune in 1989, it discovered a storm the size of an entire planet tearing through the atmosphere, later nicknamed the Great Dark Spot, and confirmed Neptune had rings of its own. That flyby was also the last time either Voyager's cameras were ever switched on. Instead of shutting the spacecraft down once the planetary tour ended, Mission Control turned it outward toward the edge of everything the sun controls and simply kept listening. Bolted to the side of both Voyagers is something worth understanding before we go further, because it reframes everything that comes after. Each spacecraft carries a gold-plated copper record, assembled by a committee led by astronomer Carl Sagan, holding roughly 90 minutes of music from cultures across the planet, greetings recorded in dozens of human languages. Natural. Sounds like thunder and whale calls, and more than 100 images physically encoded into its grooves. Instructions for actually playing it are etched directly onto the cover, in case whatever eventually finds it has no concept of what a record even is. In 1977, it was less an act of science than an act of hope. A message sealed in a bottle and thrown into an ocean so enormous the odds of it ever being found are close to zero. It's still out there right now, riding on the exact same spacecraft responsible for the recording this story is actually about. The sun sits at the center of a massive invisible bubble called the heliosphere, carved out by the constant outward stream of charged particles known as the solar wind. Everything inside that bubble, every planet, moon, and asteroid in our solar system, exists under the sun's direct influence. Beyond it lies something completely different. True interstellar space, filled with leftover plasma, radiation, and magnetic fields from other stars that lived and died long before our solar system ever formed. For decades, scientists assumed that boundary would be a gradual fade, a slow transition stretched across an enormous distance. Voyager 1 proved that wrong first, crossing into interstellar space in August 2012 at a distance of about 121 astronomical units, roughly 11.3 billion miles. Particles collapsed almost instantly, cosmic rays from deep space surged, and the magnetic field's direction shifted. Voyager 1 became the first human-made object to leave the solar system and held that title alone for 6 more years. That left one open question. Was what Voyager 1 found unique to its specific path, or a genuine physical boundary any spacecraft would encounter from any direction? The only way to know was to wait for Voyager 2 to reach that same frontier from a completely different angle. On November 5th, 2018, it did, crossing into interstellar space at about 119.7 astronomical units, just over 11 billion miles out, 41 years after launch. Its instruments confirmed exactly what Voyager 1 had shown 6 years earlier. This wasn't a coincidence tied to one spacecraft's trajectory. It was a real physical edge to our solar system, now measured independently by 2 machines, from 2 directions, years apart. In November 2019, 5 separate papers analyzing Voyager 2's Crossing were published together in the journal Nature Astronomy, each one built around a different instrument still functioning on the aging spacecraft, together forming the most detailed picture ever assembled of the true edge of our solar system. One of those instruments is where this story gets genuinely strange, and it's the one behind the sound that opened this whole thing. It's called the plasma wave instrument, and its job is to detect oscillations in the ionized gas, or plasma, surrounding the spacecraft. Here's the part that trips most people up. There's no sound in space. It's a vacuum, with no medium for a sound wave to actually travel through the way it does on Earth. What the plasma wave instrument picks up instead is electrons vibrating back and forth, creating an electrostatic wave, a completely different physical phenomenon from the air pressure waves that make sound here. But by genuine coincidence, the frequency of those oscillations happens to overlap with the range the human ear can process, roughly a few hundred to a few thousand hertz, which means if you take that raw electron data and run it through a speaker, you can actually literally hear it, not a metaphor, an audible signal. Don Gurnett, the physicist who led the plasma wave investigation on both Voyager spacecraft at the University of Iowa, described the first public playback of Voyager 1's version at a NASA press event in 2013 as a landmark moment, the first recording humanity had ever made of sounds occurring in interstellar space. While Voyager 1 was still inside the heliosphere, the tones sat low, around 300 hertz, matching the thin, hot plasma of the solar wind. The instant it crossed into interstellar space, the pitch jumped sharply higher into the 2 to 3 kilohertz range, a clear signature of colder, denser plasma pressing in around the spacecraft. That shift in pitch alone stood as solid scientific evidence of the crossing, independent of anything else the spacecraft measured. When Voyager 2's own plasma wave data eventually made it home years later, it told essentially the same story from the opposite side of the solar system. Scientists recorded a jump in electron density by a factor of roughly 20, an almost identical signature to what Voyager 1 had produced at a completely different location. That match, from 2 separate machines, confirmed beyond reasonable doubt that both spacecraft had passed through the same kind of physical boundary. Gurnett summed up what the data proved simply: the long-standing assumption that the solar wind fades away gradually the farther you travel from the sun turned out to be false. There's a real, distinct edge out there, sharper than most scientists expected, closer to a weather front than a slow transition. There was a genuine surprise buried in Voyager 2's readings too, where Voyager 1 had found the plasma just beyond the heliosphere slightly denser than predicted. Voyager 2 found it slightly warmer than expected, hinting that the bubble surrounding our solar system might be compressed unevenly, pushed harder from one side than the other, likely shaped by the sun's own slow movement through the galaxy over millions of years. That's not something anyone could have guessed sitting at a desk on Earth. It's worth being precise about how this data becomes sound, because that process is exactly why it deserves to be trusted rather than sensationalized. The plasma wave instrument doesn't create an audio file on its own. It measures the electric field around the spacecraft dozens of times a second and sends that raw numerical data home as radio telemetry, the same way every other instrument aboard does. Scientists on the ground then take those raw measurements and run them through a straightforward mathematical conversion, mapping the frequencies directly onto a range the human ear can hear without adding, removing, or altering anything about the underlying signal. Bill Kurth, a longtime member of the plasma wave team, has explained that turning the data into sound isn't about spectacle. It's genuinely one of the fastest ways for a trained ear to catch a shift in frequency or pattern that might otherwise take far longer to spot scrolling through a spreadsheet of raw numbers. The sound isn't decoration layered on top of the science. It is the science, rendered in a form a person can actually process. That distinction is exactly why this deserves more trust than a vague headline about a decoded alien transmission, not less. The raw measurements, the published density figures, the peer-reviewed papers, the named scientists willing to explain their reasoning on the record, all of it is fully documented and publicly available. A sharp contrast with how a fabricated space story usually spreads. Vague sourcing, unnamed researchers, claims growing more dramatic the further they travel from the original data. The second half of this story is a countdown, and it's already running. Voyager 2 runs on a radioisotope thermoelectric generator, a block of decaying plutonium converting heat into electricity, never designed to last forever. Every year, that power source loses roughly 4 watts. For the last decade, mission engineers have made increasingly difficult calls about what to sacrifice. The cameras went first, switched off permanently right after the Neptune flyby in 1989, since there was nothing left to photograph and no spare power to run them anyway. Since then, one system after another has followed: heaters, backup circuits, anything not essential to keeping the remaining science instruments running, and the spacecraft able to talk to Earth. It looked by early 2026 like Voyager 2 would soon be down to a bare handful of active instruments. Then, in August 2026, NASA announced a workaround engineers were informally calling their Big Bang fix, one that freed up enough reserve power to keep Voyager 2's 3 remaining interstellar instruments running for at least another year longer than expected. Right now, Voyager 2 is still operating those 3 instruments, still drifting outward at roughly 34,000 miles per hour. Still the only active spacecraft sampling this exact region of space. There is currently no funded, launched, or approved replacement mission waiting to take over if it goes dark. NASA's Deep Space Network, 3 enormous dish complexes spread across California, Spain, and Australia, deserves just as much credit in this story as the spacecraft does, catching a signal so faint by the time it arrives, weaker than the power it takes to run a digital wristwatch, spread across a receiving area the size of a small stadium, that the dishes have to combine their readings just to pull a usable data stream out of the noise. Voyager project manager Suzanne Dodd summed up where the mission genuinely stands. The Voyagers have been deep space rock stars since launch. The team wants to keep it that way as long as possible, but the power is running out, and hard choices have to be made. What remains active now is a small, carefully chosen set of instruments built specifically for interstellar work, measuring magnetic fields, cosmic rays, and the plasma readings responsible for that strange recording. Voyager project scientist Linda Spilker has been direct about what that means day to day. The Voyagers are exploring a region no spacecraft has ever entered before, which means literally any single day could be their last. But she's also noted the flip side. That same day could just as easily bring another interstellar discovery, because not one scientist on this mission actually knows what these instruments might still pick up before the power finally runs out for good. NASA's current projection is that both spacecraft's plutonium generators will likely fail sometime in the early 2030s, though the agency is careful to note that estimate could shift again, since these 2 machines have already blown past every original prediction anyone ever made about them by decades. When that day finally comes, there won't be some dramatic final message. No last transmission decoded in a control room somewhere. The signal will simply weaken past the point where even the most sensitive dishes on Earth can pull it from the background noise. And then, for the first time since 1977, Voyager 2 will go permanently silent, continuing to drift through the galaxy on its own, still carrying its golden record of Earth's sounds and images, but to no one, for longer than our own sun has left to live. That's the real story, hiding underneath a headline promising a terrifying decoded transmission from deep space. There's no hidden code buried in Voyager 2's data. Nothing NASA has released was ever kept secret and then cracked open. What's actually true is stranger and more affecting than that framing. A machine built before most people watching this were born is still out there, past the edge of everything the sun touches, sending back the literal electrical hum of the space between stars on a dying battery, with a team of scientists on Earth, checking every faint signal that arrives, fully aware that any single one of them could be among the last things this spacecraft ever tells us. If you want to be here for whatever Voyager 2 sends back next, subscribe and turn on notifications, because the true story of what's out there, once you actually look at what scientists published, is always stranger and more worth hearing than the exaggerated version.